Reaction number 3 is called imine formation. Okay, this one, the first one that we use nitrogen as a nucleophile. Okay, let's now talk about imines. Okay, imines are the compounds that possess CN double bond. Okay, so that's how we call it, imine CN double bond. All right, it's also called chip space. So Hugo Chips, a German chemist who discovered this class of compound. Anyway, okay, all right, let's do this. Ignore the so we have this one an aldehyde. Okay, ignore that for now. Let's look at the reagent. So we add primary amine, not secondary, not tertiary. This is primary amine. Okay, add small amount of acid. All right, let's do this. When you have the use, let's say, this is methylamine. This is primary amine as a solvent. So put this guy in here in this this container. Okay, and then add a small amount of acid. Okay, so what's going to happen? Let's say I add small amount of concentrated sulfuric acid. Well, sulfuric acid, not sulfuric, hydrochloric acid will dissociate. Okay, who's going to come and grab the proton from the hydrochloric acid? Water. Did we add water? No, we don't really add water. Okay, the bases, all these guys are bases. All some of this is gonna turn to be an ammonium ion. Okay, so the identity of the acid in imine formation is not hydronium ion anymore, because 1, we don't have water. Okay, 2, we have a bunch of bases molecules floating around, and this guy gonna go grab the proton right away. All right, so you cannot use hydronium ion, but use ammonium ion. Okay, so the ammonium ions, which is really weak acid, or pKa 10. Okay, not like negative 1.7 for like a hydronium ion, right? This one's just much weaker. All right, so the pronation on the carbonyl carbon, we take benzaldehyde. Okay, this pronation is unlikely to occur if you look at the pKa. Okay, the on the left side, the acid, this guy is pKa about 10. On the right side, so if some of you remember the pronated ketone, negative 1.7, negative 8, okay, these are totally go backward, 10 to negative 17. Okay, so the pronation is not that effective here. So the first step, when you draw the mechanism in the imine formation, is not the proton transfer, is the nucleophilic attack. And some of you might know that nitrogen is much better nucleophile than oxygen, than water. Okay, so this happened first. All right, so we have nucleophilic attack. All right, now what happened is, so you get a negative charge, you get a positive charge. So pronation and then depronation. Okay, so take this the acid in this solution, not hydronium ion because we don't have it. So pronate it. And then depronation. So take a base. Well, base is the ammonia. This imines basically. Take another molecule of imines. Depronation. Here we go. That's carbinolamine halfway. Okay. This compound, this intermediate, is just like the hemiacetal, but in this version we call carbinolamine. All right. We halfway now. Almost get to imines. Okay. Looks like that water got to leave. So you have to do pronation. Take another ammonium ion molecule. Okay, you can pronate either or on oxygen or nitrogen. If you pronate nitrogen, you go backward, which is also work, but it doesn't get you forward. Okay, so you want to make OH leave, so we're gonna pronate that. Okay, and then kick out that water using the lone pair on the nitrogen. Okay. And once you get to this, you might recognize that proton right there is acidic. Take ammonia and then not ammonia, please excuse me, the solvent, which is amines. Grab the proton, and that's an imine. Okay.